So what we are going to demonstrate today is the famous experiment done by Hans Christian Oersted in the year 1821. What it shows is that the electric current has a magnetic effect. In other words, that electricity and magnetism are not different phenomena but are related to each other in a very basic kind of way. So what we are essentially doing is we are taking, this is a source of electricity, maybe a battery, and this is a key, and this is piece of wire which goes to, this is essentially a device to increase or decrease the current in the circuit called the rheostat. And then the wire comes back along this path through a machine, through an instrument called the ammeter, and back to the source. So the essential part of us here is that we have kept these compass needles, two of them, one below the wire and one above the wire. And initially, when the current is not switched on, the compass needle points in the geographical north-south direction, the way they are shown here. The moment this current is switched, the key is plugged, and the current flows in the wire, we will notice that the two compass needles show a deflection. One of them deflects in one direction, the other in the other direction. One is below, the other is above. This clearly shows that the electric current produces an effect on the magnetic needle. And that's what we are going to show in the experiment. So this is the setup of the experiment. You can see that this is our source of electricity. This is a battery eliminator. Essentially, it is converting the alternating current from this source, and it is converting into direct current, and the amount of current and voltage can be regulated. So from here, one wire goes through the key. This is the key. This is unplugged right now. And then this wire goes to this rheostat. This is the variable resistance. We can move one end of this one. We can move it little bit this side and that side to change the resistance of the wire and hence the current. Then back from this, the wire runs back along a straight, more or less straight path. I wish I could make it even more straighter, into the ammeter, which is essentially, it measures the current. Right now it is showing 0, and back to the source. The whole experiment is here. It's here. I see I've kept a compass needle. I've kept a compass needle below the wire, and right now it's pointing north. It's pointing north. If I can adjust, yeah. So essentially, this is the direction from the physics lab towards the bio lab. That's the general north direction. So it's pointing north. And we are going to see what happens to this deflection when a current is run through the wire. So what you need to see is that when I plug in the current, what deflection you see in the magnet. So there we go. So I'm going to plug in the, okay, so as soon as I plug in, you can see the deflection. There. Do you see the deflection? The north pole is deflected to the right. And you can see the current also is flowing in the wire if I focus on the ammeter. And I do all at once, I'm not very sure. No, but then the wire doesn't become tall, so I'm not going to do that. I'm just going to repeat the experiment. So I'm going to plug in the key, and the current will flow, and the deflection of the ammeter of the compass needle should be observed. There I go. If I increase the current, I can do that by adjusting the rheostat. The deflection should increase. Just see. Now I've increased the current, let it come to rest. Yeah. Now as I plug in, you can see now the deflection is much more pronounced because the current has increased. Now I want you to watch both the compass needles. There are two of them right now. One I have placed below and one above the wire. And you can see right now there is no current, it is unplugged, and there is no deflection. Both are pointing to the geographical north and south. So let me adjust this a little bit, yeah. So both are pointing to the geographical north. Now as I switch on the current, you should observe the movement of the two compass needles. There we go. you can see that the movement are in opposite directions. The deflection of the one on top is opposite to the deflection of the one in the bottom. Only thing, the wire is somewhat very far away from the one on the top, therefore the deflection is much less. What we can do is maybe increase the current and see it once again. There we go. You can clearly see that the deflections are in opposite directions.